So good morning, everyone, or good afternoon, depending on what time zone you're in. This is the ESNet CI Engineering Brown Bag series. And today we are privileged to have Rick Wagner from Globus to talk with us about automating research data workflows. In terms of questions and so forth, let's have people drop questions into the chat if that's okay. And we'll batch them all up for the end, I think, rather than try to do the questions in line. And we'll take it from there. So Rick, thanks very much for doing the talk today, and I will hand it over to you.
All right, thanks, Eli. I think a lot of us know each other. I certainly recognize some of the names in the chat. Rick Wagner, I work for Globus on the professional services side. Basically, I'm the part of Globus that where the staff that gets embedded in projects. And what I wanted to cover today is some of the things we found and tools that are useful for when you're trying to just handle a lot of routine, not necessarily simple, but common research data tasks, like the migration of data from an instrument or staging data from a portal or other things that I've got some stuff here that you can compose and adapt to hopefully make things a bit more robust for you. And I'll keep an eye on the chat, but Eli can also chime in if audio is bad or something like that. And I got to call out, I noticed that in the chat, it's got a go slower and go faster button. I don't know if those are like for voice modulation or something, but there's obviously features of Zoom that I don't understand. So, all right.
So Rick, just FYI, your audio is coming through nice and clean. So you sound good.
Good, thank you. And there was a helicopter overhead a moment ago, but I assure you that had nothing to do with what I did this morning. Okay, so back to PowerPoint. Most of you are going to know Globus. I'll just cover it briefly. Globus, what do we do? Fundamentally, we run a hybrid SaaS model that is all about reliably copying files. We have a service that runs inside of AWS that manages the transfer of files. So a lot of this talk is about how to talk to that service, because that service can then coordinate the movement of data from a source endpoint to a destination endpoint. And one way to think about it is, yes, we go fast. The ESNet Science DMZ model has really helped to enable that, but also it's about reliability. It's about getting the same data from the source to the destination. So verifying integrity and things like that. Also dealing with storage and network failures. If you're running a cron job that's doing an SCP or an rsync on the same host that is copying data, then if the source goes down, then it's likely to go down. So by having it in the cloud and talking to our service, we do stuff like retrying. So if we see a temporary failure, we back off and retry, and then we validate the data afterwards. And one thing of the validation that is a new feature that's in the API is we also support you can specify your own checksums now. So what that means is you don't have to trust the source to be the point of truth for the validation. So if you're running a portal and you've got checksums for all your data, you can now actually call the API, specify your checksum and your algorithm, and as long as both endpoints support the algorithm, like MD5, that'll always work, but SHA-256, 512, those should also work. It means that if there's something that happened to the data while it was resident on the source, you can actually verify it. So yeah, like I said, we go fast, but it's about getting the data from point A to point B reliably without you thinking about it. It's hybrid SaaS, so everything that is above the dashed orange horizontal line is customer managed, whether that's the same customer or different customer. And I say customer in the sense of you all out there operating your system. So the data owners is another way to say it. And then there's what we run in the cloud. And of course, we support the concept of sharing, basically where delegated access control. So a appropriate user can create a endpoint on top of a shared endpoint, an abstraction on top of a quote physical one, and then manage ACLs and permissions through Globus itself. And this is really powerful when it comes to automation, because something that I don't go into heavily here, but Endpoints require you to activate them. You have to authenticate to an endpoint. And there's two cases where Globus will auto-activate. One is it's a personal endpoint. It's like the one I'm running on my laptop, and that is owned by me. So because I own it in the sense of Globus, if I want to move data in and out of it, Globus can say, is that endpoint still there? Do I still have a valid account, et cetera, and make the decision whether or not to access the data. The other kind of endpoint where that applies is a shared endpoint, because a shared endpoint is not a multi-user endpoint. It is a point on the file system that access has been granted to by a particular user. So it's owned by a particular user, and then that user or their delegates can specify permissions on it. And again, you've got that sense of who owns that endpoint, and we can do auto activation. That's critical for automation tasks, because you don't have to periodically activate and authenticate to the endpoint as you would when you're just moving data around on your own. So I've seen that time and time again, that if you can get away that you're dealing with shared endpoints on both sides, you can have cron jobs going all year long, copying and syncing your data routinely without a bunch of hands-on and key management. All right, so that's Globus background. The other part is you're talking to the service, the part in the cloud, and you're doing this fundamentally through a REST API. So if we start at the bottom, it says REST APIs. You can talk directly to that service using JSON and HTTP requests, et cetera, et cetera. We then have an SDK that we wrap up into a CLI. We're going to touch on the CLI quite a bit. And for those of you who are still thinking about previous versions of Globus, like Globus URL copy, that's not what I'm referring to. What I'm talking to here is a Globus command line interface that is basically sending commands to the Globus service. So it's a wrapper. This is what you want to use when you're scripting and doing other stuff. And it's kind of a bridge between full-blown programming and the command line. And then we've got the web that most people use, where you log in and you've got your files on the left, copy them to files on the right, delete files, stuff like that. All the things through the file manager that most people are using, but you can't automate it, but it's still really useful. And so it's all about how do we talk to this service. So here's the classic use case. And you can think about this in different ways. There's projects out of like Oak Ridge where they're copying data routinely from reactors and stuff like that, and they need to get it to different places, and they want to synchronize it over to Berkeley on a regular basis. And the quicker they can do that, the quicker it gets ingested into the research flows and stuff like that. You have instruments, you're collecting data from cryo-EM, and you're buffering it inside of your laboratory or inside the building, but then you want to stream it out to campus or other resources for backup. You have a compute job that's running and it's going for a couple of weeks, and there's key files you want to trickle out every day to do analysis on. So recurring options, this is basically how do you do rsync-like stuff with Globus. Once you get this enabled and this kind of concept, the same thing applies if it's, I've got a web portal and I want to provide access to data. Well, I find the place where I want to put it and then I submit my command. But data replication is kind of the classic canonical use cases. I've got something over there that's making data that's important to me, and I want to get it over here. So how do we enable that? One of the fundamental capabilities that we use for this is it's the idea that the endpoints are their own thing. The Globus service is its own thing, but we need something to talk to the service and potentially the endpoints to do it. And one of the key ways to do that is a native app. Native app is the idea of like your iPhone apps. Those iPhone apps, when they get distributed by the store, they don't have any of your secrets in them, and they should not, they're not really trusted. So the role of a native app is to, once it's installed, to have a way to securely store some of your tokens and then use them for stuff. And the idea that we're talking about here is installing something like a script or the CLI tool, and then it stores some keys similar to the way SSH keys are stored. In fact, a lot of our models, when you look at it, we have hidden directories or hidden files inside of your home directory that are locked down. So if you trust private SSH keys in that context, you can manage these in a similar way with a few caveats. So we enable native apps through the use of our SDK. And although this is all OAuth and OIDC standard compliant stuff, so you can do it on your own. If you're distributing a Jupyter notebook and you want to have some examples of how to call APIs, a native app is a good way to go about it, and much better than embedding any secrets in a Jupyter notebook that you're going to distribute. So the way to think about a native app, Grant, is I've got a user accessing with a browser, but they're logged into a system or they've got another client. Now this could be an actual application like on their desktop or something, but let's think about I'm SSH into another client, or I'm on my laptop and there's a command line tool that needs to do command line-y stuff, even if it's calling APIs. How do I get tokens into it? So first thing the user does is they launch the application. And when that happens, it sends back launches the browser with a URL to authenticate. So now the browser is saying, oh, well, I know where to go. I get redirected. I go talk to Globus Auth. It talks to an IDP, consent to the usual grants, and an auth code flows back to the browser, and then it talks back to the application with an auth code. The auth code is a temporary code. It's not the actual tokens, so the tokens are then exchanged. So code goes back, access tokens flow to it, and now that you have access tokens that the app can store, it can call out to the transfer service. This is also, we cover, if you're headless, for example, like you don't have a browser, you're SSH into something, you can do copy paste with these URLs to actually go and get your auth code. So now you've got a tool, a native app that can call APIs. It doesn't necessarily have to be Globus Transfer, although that's the one that we're going to work with the most in this example. The other key thing to think about, like I said, SSH keys. So private SSH key or a certificate has some drawbacks. And the main one of those is like they're very, very long-lived and they have incredibly large scopes. You can use them to do a lot more than is, there's a reason why we're moving away from them for various things. But what if I have a script that I want to run as a cron job on a system as me, but access tokens only last, sometimes they're very short-lived, like on the order of minutes. Sometimes they're a couple of days, but if I'm running a cron job and I don't want to think about it, the idea is it should run for years unless something changes. So we have this concept of a refresh token. And the key part about a refresh token is it has to be used every so often. And as long as it gets used, it'll keep extending its expiration date. So the refresh token can only get new access tokens. The access token is the thing that actually talks to a service. The refresh token gets you new access tokens. In some sense, that sounds like, well, you're not any better than SSH or something, but in reality, you can revoke these. That's the special part here. Is unlike a cert or SSH key where I've got to go find out everywhere I put that private SSH key or my other key API token, here, I can have an application that I have instantiated on my laptop or some other system and revoke just that without blocking my access to everything else. So it gives you more granular control. So the other caveat to it though is that refresh tokens are powerful in the sense that they can keep extending stuff. So if somebody gets the client and refresh token, they can potentially keep getting access tokens and doing stuff. And an example for that is like we have a public Jupyter Hub server that I've got to remember to show you. And we don't store or cache the refresh tokens on that because it's for training and demonstration, and we try to maintain it securely, but it's a demo server, and if it gets compromised, we don't want every single training user out there to have their refresh tokens exposed and potentially enable access to other services. So by blocking refresh tokens, we mitigate some of our risks of exposure. So it's just a concept you have to understand in this space is whether or not to have refresh tokens. If you want a persistent service, you either have to do refresh tokens or some type of client secret. If you just want to have something where somebody can log on occasionally and do something like our training server, maybe you don't need refresh tokens. So here's the refresh token example is you've got your auth code and you take your code and you get the refresh tokens, you get your access tokens, and you store them, and then you can go back and get new access tokens. And you get access tokens, you call the service. So if I haven't logged in for a while, this all happens in the background, the user doesn't see it. All right, so here are some examples about how to use native apps building on the SDK. But I'm gonna say, if you want to build a script, and I'll show you an example one that we built that's designed to work for E3SM, the climate science project for distributing data. We have a package that is basically, it's a native app login. It uses the Globus SDK, and it makes it very easy to specify the scopes like transfer or identity and things like that, whether or not to have refresh tokens and other stuff. So if you want to have your own script to do special things for your project, and it's like, well, I could wrap the CLI in a bash script, but that gets kind of complicated. I could use the Globus SDK, but then I got to handle tokens. This might get you there a little bit quicker. And especially if you're like, well, what I really want to do is use Globus Auth to enable my own APIs and write custom CLI codes to say like, download job status or research results, or to do a little bit of processing. We use this package, for example, for projects. There's a group out of USC at ISI that does Deriva. It's a data catalog. All of their security is based on Globus Auth, and their client uses this for login. We have an identifier service that mints digital identifiers. This is how you log in. It saves you for some boilerplate, and then you can configure things like how you like to store, how to store the tokens and stuff like that. By default, it'll handle multiple applications and stuff, but if you need to write custom scripts for various things and you want people to log in using Globus, here's a package that'll make your lives easier. All right, let's start to get our hands dirty. So let's talk about the Globus CLI. So Globus CLI, this is actually the reason we wrote that other package is the CLI is a native app. It's a Python package, wraps up the SDK, has Globus login, and uses access tokens. So unlike before where you had to run persistent service or persistent processes to manage the data transfers, or when we first started with the more online presence, log into a server and then run tools on that server. Now you're basically running a wrapper around the SDK, which calls our REST API. So things are quick and responsive, and you can run it everywhere without it being a huge hurdle. You certainly don't have the same overhead to install it. So let me show you an example. How readable is the terminal at this moment?
It's good.
Great. All right. Globus --help. We always like a good help parameter, and we've got that. So it's written in click, so it breaks out the various commands. The first ones we're going to see are log in and log out. So if I do Globus, who am I? I'm not logged in. Globus login --help. So it gives me the commands. The only reason I ran the help is here. If I were to run no local server, what it would allow me to do is it would give me the URL, but I'm going to instead just do the quick and easy one, Globus login. It takes me to Globus. I pick how I want to log in. Who do I want to be today? I'm going to be University of Chicago. Go to University of Chicago. I'm being redirected to my own identity provider. I see HTTPS. I see the right logos. If I hadn't logged on last week, it would have sent me to Duo. Here's my grants. So I am granting this application, this install on my laptop, permission to call the APIs. And we've logged in. I'm going to close that tab and go back to the terminal. I've successfully logged in. Now if I do Globus who am I, it's going to go talk to Globus auth, and it's going to say, there's my primary identity. All right, so that's the basic login. I hope you like UUIDs because they are everywhere. We needed some unique way to identify various things like endpoints and tasks and identities. So you can do stuff that whenever you end up with something, that's going to be the key that you want to hold on to manage stuff. So if I do Globus endpoint search Rick MacBook, we're going to get a UUID for my Globus Connect personal endpoint. I could also do something like LBNL. Let's see. Ooh, there's either a lot or none. All right.
There's a lot. Go ahead and dump out the ESNet DTNs too.
Yep. So there's a lot. Been working a lot with ALCF. I'll see an example of that. Oh, why do I have a feeling that that's related to me? This one is, so yeah, you can actually see who owns them and stuff like that. I'm going to grab one of these. So let me grab this example here. So I'm going to grab the UUID. Globus endpoint -- help is activated. So I mentioned activation. Basically, have I authenticated to that endpoint recently? This endpoint is not activated. And it tells me a little bit about how to do it. Let me go back and look at my laptop again. Does not require activation because it's auto activation. So gives you a little bit of information, stuff like that. But if you're troubleshooting like why the data isn't moving, way to check activation. And like I said, welcome to the UUIDs.
So Rick, sorry to interrupt here, but I noticed that the exit codes were different, right? And so my understanding is that this CLI is really just a wrapper around the standard Globus API. And so if you were doing this programmatically, right, you would have gotten that endpoint, you know, as part of the results of getting the list. You'd poke the thing, you'd come back with the exit code that says, hey, this isn't activated. And that's a prompt for me to then go and call this to go activate it. And that's all machine consumable.
Yes, and this is where we get to the realities of a REST API and its status codes versus what we want to see on the CLI. So if I'm wrapping a script and I want to know if an endpoint is activated, I kind of want the 0 equals good status and the 1 equals not good status. But in reality, the REST API is going to give me responses like 200 because it's about, did I make a successful call to the REST API? Even if inside of that response is something that says this is not activated.
Right, but that's still, you would still get a machine consumable answer. And so you would be able to deal with that in a machine consumable way without having to have a person necessarily deal with every step.
Absolutely. In the same way that I could do this like foo equals that. So now I'm just capturing the literal text response from it. Echo $? The exact same thing. So if you, the same way I could wrap a script to look at the exit codes, I could have programmatic code looking at the JSON coming back from the REST API and say, I want to look for the field activated and look for true or false in there. The answer to your question is yes. All right, so there's other commands like get identities and stuff like that that you can run. Convenient one, good to know about, batch transfers. So you can transfer stuff, and sometimes you just want to say like, take this directory, and I want to copy this directory from point A to point B, or I want to copy this file from point A to point B. But one of the very powerful things that I don't know quite how often gets used is you can batch transfer things. The underlying API, all it wants is a list of source files and a list of destination files, and they don't actually have to align. You can take, as long as they're coming from the same endpoint and going to the same endpoint, you can rearrange and rename files on the fly as they're traveling, as you're saying, because it's going to say like it has the opportunity to rename stuff when it writes the new file. So here's an example of doing a transfer where we cat the input in. But what I wanted to walk you through, no, safe resubmission. No, let me walk you through this first example. So let me show you quickly, and there's lots of links to this in the slides. Here's a basic how-to on using the CLI. And in this case, what I was doing is I had a set of files that were in 2 different directories on ALCX Theta, and I needed to get them to one of our endpoints on Petrol for E3SM. So to do this, I went and looked up the UUIDs for the 2 endpoints that I was interested in moving stuff to and set them as just temporary environment variables. If you move stuff between endpoints a lot, you can either embed the endpoint UUIDs in your script or maybe in your bash RC and have them available. I mean, if you want to memorize UUIDs, go for it. But I'd like to think about words like theta and petrol. So the runs were split. Something's not right. That should be run 2. Anyways, so there was 2 runs that we were working with, and I had 1 destination. So I verified the activation of my endpoints, and then one of the things you can do is you can either list files locally to build the list that you're looking for, or you can use Globus. So you could do this on you could do this on a system. Like I said, I was doing this on my laptop. So I was not logged into Theta to do this, and Petrol only talks Globus, so you can't log into it. So on my laptop, I was listing files, building a set of source files, and then I didn't want to rename them, but the list has to be like source file name destination. So I just did source, and built my list and ended up with a couple lists of files and submitted the transfers for them. So after it's submitted, I can sit and monitor the task, but pretty much it's just going to keep going until it succeeds or something goes wrong. And then when it landed at the new one, I did a sanity check. So again, you don't have to memorize this, but I wanted to show you, like, this is an example of how to build a list of files on a remote system and then submit the transfer for them. So you could, again, cron job this or do whatever you need around it. If you wanted to have safe resubmission, say you're like, I'm generating lists and I'm submitting a transfer, but in case something goes wrong, I don't want to resubmit it and like have the data copied a lot, you can pre-create a task UUID and then submit the submission ID, and then as long as you reuse that ID, it would not resubmit the same task. You can change how you filter the output of it. You can have it come out in JSON. There's James path, which is really useful to get specific elements of the JSON out of it. And then it's got some standard like tabular output. So parsing the CLI output is pretty straightforward. There's my batch MD walkthrough that we just did. So listing files, creating batch transfer. You can turn off notification emails. So normally if you submit the transfer, you'll get an email. You could imagine if you got 5 cron jobs running every day on 20 systems, that might not be how you want to monitor it. You might want to monitor the tasks through, it'll almost always, you know, if you turn off notifications, you can turn off specifically like succeeded. You probably want to keep the failed on or something. So that's up to you. You can decide how to tune it. Another thing you can do, especially on shared endpoints, is set permissions. So if you create a shared endpoint, you can be the one to set permissions on it, but you can also delegate access. And this is really good for projects where, for example, an administrator at LBNL stands up a shared endpoint because it's part of a project and they want to make sure it goes to a certain directory, but then they can grant access control rights to a PI or project lead and say, hey, I own this endpoint because we don't want it to go away, or we want to keep control of it. And all the data needs to get written into this special systems account, things like that. But you can delegate access. And so if you have access manager roles, the PI or project manager can go in and go like, oh, I need to add this person to the project. They need to get access to this data. They can do it through the web app. They can do it through the CLI. You could do this as part of an onboarding script or a data distribution. Like if you're using the instrument case, you could say, I've got this shared directory that I'm using to distribute results from an instrument to a customer who's not part of my organization. It's like campus core services at UCSD could do stuff like this. Set up the endpoint, and then at the end of the job, run a quick script and it sets the permissions for the customer, and you send them an email saying, hey, the copy of your data is over here, please go get it. So going back to our classic use case of copying data. So if you wanted to put the CLI, let's suppose you wanted to deploy a tool like this, the admin would get on the head node or some other node that's kind of reserved for management, and you do the Globus login. So you, the admin, are logging in as you to the application. So we know who has to talk to stuff. This isn't like a root script. It could be, you could decide how you associate your accounts, but then that script gets called at certain times, for example, when the jobs are run or data is generated and stuff like that. So yeah, different ways to manage the how you deploy the script and stuff like that. If you're doing this in the case of a web portal, that's where we say it's probably not the CLI job. You really want to do this with the SDK, and you use the user's tokens to talk to transfer because they log into your portal, and the portal is the one storing them. So that's the whole MRDP model. I'd be glad to talk to anyone about that. All right, so let's walk through another example of why rsync should die. So if you have systems that you need to routinely replicate data from, either because new data is being replicated or you want to use it as a backup mechanism or something like that, here we have an example using the CLI that's pretty understandable, that if you were to log into a machine with this script, store your tokens, and run it, it will submit a transfer from point A to point B as often as you like it to. And like most good scripts, it actually checks to make sure that that transfer is not currently running. The example here uses our tutorial endpoints, which you can go check out. We have endpoint 1 and endpoint 2. There are some example data paths, and it copies to your home directory on the second endpoint. So the things to know about this script: source and destination endpoint UUIDs. So if you wanted to take this and hack it, you would start there. Source path and destination path. It's going to do a recursive transfer. So all the data under this, there's no wildcarding here, things like that. Obviously, you could modify this to do a batch transfer, but primarily it's like, I want this directory routinely copied to here. And we're going to track the ID of the last transfer. If you're familiar with rsync, you've got the same options. I don't have as big of a problem with rsync on a local system, but as soon as you get to network file systems and distributed systems, that's when my dander gets raised. So, but we need the same options. There's a reason why those options are there. So here we're going to use checksum. So we're going to copy all the files that aren't on point A or point B from point A, and then we're going to checksum to make sure that they haven't been changed. So this way you'll get the right copy or a valid copy every time. Here's some boilerplate. about checking status messages and stuff like that. All right, so the first thing we do is, if we have a file that exists with a transfer ID in it, we're going to check and see that if it either succeeded or it failed, we're going to resubmit. If it's still running, we're going to let it keep going. So this is actually a lot of code to wrap up a couple of commands. One is this right here. What we check for is the destination, or the source rather, a directory? Because this is a recursive transfer, so you can only do that. You can't do a recursive transfer on a file. Then we submit a transfer. We want the output text to be in Unix this time because we're looking for the task ID. It's a recursive transfer. You can delete files on the delete the destination if it already exists. I believe that's what that flag means. Checksum sync, source, destination, call it a day. So this is the straightforward way. Like if you have a nightly or daily replication task, here you go. Take this, modify it, it'll just work. All of these commands get executed as the user that is logged into the Globus CLI in the context this gets run as. So you could log into a root account, especially if it's a limited set of administrators, and say, all right, only I am allowed to log in to the Globus CLI on this system under root, just document it, talk to everyone, and then this will run as you to move data around. Or it doesn't have to be a root account. It could be like an administrator's account on a system. And if you wanted to use the SDK, this is an example of doing the same thing. Using this, it logs in, it gets the same tokens, things like that. This needs to do, we have a pull request to update this to use our native app because it gets down to the basic one where it's doing the same thing. It's checking to see whether or not the last transfer runs, checks the destination of the folder, then creates it. So if you wanted to start building a portal or a more complex framework than a script is required for, here you go. We've got examples for that as well. Okay, so let's talk about a custom example. So something that's not just straightforward replication. And I'm going to take this example from something we did for E3SM. So E3SM, large systems model simulations done on big machines at ALCF, OLCF, NERSC, stuff like that. Primarily at this moment, all the archiving is happening at NERSC for the E3SM data. But the data is published to the Earth Science Grid Federation as part of the Climate Model and Comparison Project. Basically is the Earth warming study that requires data from all over the world to see what we agree on. And the data's got to get distributed internationally on different continents for a variety of reasons. Like, we really are worried about disaster recovery for a project of this scale. And so we've got to take the data from NERSC, manipulate it in various ways like regridding and standardization of units and variables, and then aggregate in a single location for publication on our nodes for the ESGF in the US, so that our colleagues in France and Australia and elsewhere can pull it and get it out to various places and get it out to their systems. And along the way, because the data is moving between different places, we've been bitten by silent corruption. File systems get big, they eat data, networks eat data even though they try very hard. And nowadays, any file system bigger than your laptop is built on a network. So I don't care if it's got InfiniBand in the background or some other RDMA fabric, it's still a network. As hard as that ZFS storage is going to try and work to keep your data safe, it's only one portion of it, and then it's networked together somewhere else, and there's a lot of places for failure. So you not only need to get the data from point A to point B, but you need to have ways to ensure its integrity in various places. Plus, we got here is getting the data from tape and things like that. So here's a picture of kind of what we're talking about. You've got the data stored at NERSC, and it gets stored on a tape. And then we use Globus to get the various components like the atmosphere and ocean and sea ice and we run different pieces because it's a lot of work and it's kind of nice to have different resources to run on. We fan it out, we do the transformations, we reconsolidate it back at another location, and then we publish and register it to ESGF. So there's a lot of data moving around, and it's going, we're talking about hundreds of terabytes here routinely, going to different places and taking on different shapes as it goes. So it's a complicated data process, but it's not, it's only run by a few people because it's kind of specialized. We have a fixed flow that's messy, but it's got to get done again and again. So it's not like there's a huge infrastructure and code to do this. It's more like one person working diligently. And to do that, it's nice to have scripts and workflows that make things more routine and can capture work processes and things like that, the same way that plumbing or ducting in HVAC and stuff like that keeps things the same and standardized. So we wrote something that's called a data stager, and the data stager uses the login package so that we get transfer tokens, and then it implements the logic we need to perform the transfer. And its job is, E3SM uses a tool that they call Zstash. Zstash is very nice. It'll take a list of simulation files, bundle them up conveniently to talk well to the HPSS archive, generates checksums and stores the checksums in its own database, and then it stuffs the files in HPSS. So we use it in reverse, which is we say, I'm going to log into Globus. I'm going to get my tokens so that I can talk to Globus. I'm going to talk to Zstash and say, get me files with names like this, drop them here, help me build a manifest of the files that I want to transfer. And then I'm going to submit a transfer to take these files from NERSC to the system that I need to work on, and I'm going to send the manifest along with it so that we can track the files later. So without a script like this, what you end up with is a user logging into a NERSC login node or maybe a compute node, pulling a bunch of files and just having a long running process in their terminal. And you can see how this gets fragile, right? They pull the files, they're waiting on tape. And when in reality, you can sort of encapsulate this. So here's the README for it. It's a single file that accepts things like, tell me where you want to send the data. We assume some things about the source. We try to look it up. Which archive, so what database of files am I talking to in the Zstash? Here, tell me the pattern files. This is the project, has specific keywords and descriptions in the file names that we can use. And otherwise, what it looks like is you log in, get your tokens, and then you run this. You say, go get, here is my Zstash file, give me the atmosphere and ice, and send it to this destination with these file names. So this is a way that if you have a routine work process that you need to follow to get data from point A to point B, you can encapsulate it in something that's a little bit better than just a small SCP script, but now you get all the Globus functionality in terms of transferring things. And we've got logic in here that actually, like I said, talks to Zstash and gets the file manifest to send it along as well. This is what the code looks like, because it's lunchtime and I know that code is the best way to put everyone to sleep. You know, we're able to store the UUIDs for the various endpoints, define our patterns, the scopes, as I mentioned, so you can limit what type of access tokens you're going to get when you use the login. This is what it looks like to use the login information. If you've already logged in, you only need to do it once. And then along the way, you basically see it doing file stuff and gathering things and then building the manifest and sending it out. So again, the reason I include this is if you've got a use case like this, please take the code, reuse it, make it do what you need. And here's a tool that can use Globus, but really doesn't have a lot to do with this. It's kind of like my other piece of advice. So speaking of manifests, I'd like to point you to a tool called BDBag. BDBag is based on the Bagit protocol. Bagit is very straightforward. It is a zip file archive. You can also use tar files. That is a standardized way of including a data directory with a bunch of files, a manifest of the checksums of them, and a little bit of information about who created this. If you are routinely packaging files for distribution as archives and sending them outside of your system and project boundaries, please use Baggit. It's used by the Library of Congress. It is not complex, and it sends along a manifest with the files. So when that tar file that you send gets unrolled somewhere, let's suppose you're distributing reference data sets. You've got reference data sets, and you're like, download this, this, and this, and here's all the checksums. BDBag and other associated tools based on Baggit there's a ton of command line utilities and others where at the 0 level, it's a zip file or tar file. I know how to extract it. I could figure out how to interpret the manifest, or I have tools that can do validation on this that are easy to install and really good for data curation and archival work, but also just generally, if you're distributing files, why not generate a BDBag, have that posted somewhere, install the BDBag CLI on a system, and routinely Globus or wget your reference data sets down, unroll and validate your data. So now you know that you've got the exact reference data sets. You can also revalidate stuff. So we're sending along manifests with things. Well, maybe every couple of days, I want to rerun it. And this is where I think it's very relevant for those of us working with large-scale distributed systems where there's kind of a user or project context. We're not all working in the context of one single data archive where we can have systems that will routinely validate all of our data. We have certain things that we have to do on our own if we're the ones logging in for our project. And so BDBag also has another key feature for us, which is that Baggit traditionally, the default spec is to have all of the data included in a data directory. You can have subdirectories and things like that, but the data is there. By using a profile, an extension of the Baggit protocol, you can have, quote, missing data or a holy bag that has a fetch file. The fetch file is simply, it says, here's the manifest of files that you need to go get from some type of URI that your client tool, the BDBag client tool, can interpret. And so, like using the reference data set example, maybe the BDBag itself is just a manifest with the checksums and the fetch file, and then the actual reference data sets live somewhere else. You've got your manifest and checksums inside of the BDBag. Your client tools can understand how to interpret it and pull it down. And one of the reasons I promote this is it's a project that Globus uses, we don't create. So it's not like you're not fixed with us. You can use HTTPS, it talks to S3, stuff like that. But I think it's very useful that if you're distributing places, otherwise you'll end up writing this stuff on your own. This is what the inside of a BDBag with a manifest would look like. I crack open my zip file, I look inside of it. There's various places you can embed metadata. There's research object or RO metadata you can put in here, but mainly we've got our manifests and our fetch files. And if I look at the manifest, what I see is, I see the data that even if it's not in the bag in this data directory, I see their checksums so that I know when the data is there, I know what it should look like, or I know what the checksum should be. Then I've got the fetch file, which says, go to this URL, and that's the data. And here's the other powerful part. Just because there's a URL or URI in there does not necessarily mean that you have to have access to it. You can distribute BDBags with references to data, and only if the client can get the necessary tokens or credentials to access it. Distributing a description or manifest does not expose the data. It's like, as I've said before, like my motorcycle has a license plate number. I'll give you the license plate number, but you need to ask me very nicely before you ride my motorcycle. Same thing when it comes to the data. It's, again, a Python-based application. So you run it, and it's basically BDBag, do a bunch of stuff on the path. The two that I want to point out, number one is validate. So you've got your BDBag there, your reference data sets that you want to check. Instead of writing your own for loop, here's your choices for the level of validation you can perform. The other one is the Materialize. So I want to materialize a reference data set on a remote system. It's got URLs or URIs for things that I know I can access. I'm just going to go and say materialize it. And number 4, full validation will be run. So if I was distributing data, say for processing, I could use this and send the remote or send the references as the BDBag rather than sending along all the data, materialize it at the other end, and it's going to sanity check it for me. So I know I've got the right data, and then on it goes. And maybe my results, I do the same thing. I generate a BDBag for my results. They're literally a zip file with some text files inside of it. Not too much to worry about manipulating. Here's an example that we're using in the context of the NIH. The Common Fund Data Ecosystem, we're receiving metadata in the form of like TSV files and whatnot, and that we're processing and putting into a catalog. And we wanted a interchange. We wanted to agree on a interoperable, exchangeable format for stuff because of reuse. So as the data coordinating centers begin to give us metadata, we put them into BDBags as kind of our unit of metadata. This might be the manifest or description of a data release. It might be a small update, something. But this way we can store them in a repository and say, hey, I got a bunch of files here. I can track them easily. And inside of that, I have this metadata that is exposed over somewhere else. Gives us a way to go back, repeat our ingest process. And then if somebody says, I want to enhance or enrich or something or reuse the data, they don't have to necessarily talk to our catalog and know how to work with it. We can instead say, well, if you've got the right access, you can get access to the raw metadata and do your own digging. So another example of how you can use BDBag for stuff. All right, and the rest of it is a bunch of links and references and things like that. And so is a good point for discussion. And maybe we can talk with Jonathan about what they wrote that was similar to BDBag.
Many thanks, Rick. That was great. I'll say again, folks, please feel free to drop questions and such into the chat window. Jonathan, I think if you want to take just a couple of minutes, if you can, and talk a little bit about what you did at MSU. I don't know. I mean, maybe what we need is to have you give a brown bag talk as well, depending on how in depth the project is and how far you want to go with it. But a little bit now would be great if you're willing.
Yeah, I can give a quick overview. The basic idea was that we had to deal with transmission and archival of data sets, file collections, which were not amenable to transfer. So users who had thousands to millions of 1 kilobyte files, Globus does a great job, but that's a problem. And likewise, on the other end, we had people who had, 100 terabyte sparse files. Those also are kind of messy. And so our objective was to use the Bagit as the final tool, but before doing Bagit, to what we'd call compress and normalize the file. So it's a configurable setting where you could try to generate files that are about, anywhere between 10 megabytes and, maybe a few gigs, depending upon your need. And then in a kind of responsible way, document how you handle that compression and splitting. Throw that metadata together along with the compressed and split files and roll that up into a bag. And then the final result would basically have an index where you could see both the compressed files, and those would be verifiable and everything that Bagit provides. But at the same time, you'd have access to search for text files that contain information about what was in those files. So users could search and look for things without having to extract the whole thing.
I see. So that I mean, that's sort of a making your data set storage friendly. Because I mean, anybody who's had to deal with storage systems know that, single, 100 terabyte files are hard. and 1 million files in one directory, LS can take half an hour. So, obviously those extremes are to be avoided if possible.
And John, the one thing you point out, one of the other reasons to use the CLI when interacting with Globus is, the web app can only do so much, and users, once they start to use a directory structure as a database, you end up with those small files. And so, the Globus CLI will transfer the files for you, but then you just end up moving your problem literally to another system. So I really like the idea of a tool that captures that and unitizes it to make the file system happier. And the more individual files you have, the more likely you're going to screw one up.
Yeah. Yep. And we kind of designed around usability. We wanted the metadata indices to be something that you could interact with on a normal desktop. And likewise, we made use of the fetch and some of the general concepts to make it so that data could be located elsewhere, so we could partition the management of data from where it was actually being stored.
That's fantastic. Very cool. Thank you. So Rick, I had a question about, first of all, Jonathan, anything else you want to add, or do other folks have questions about that system?
No, the only thing I would add is that it's not public, but we are willing to share it, and we'll probably make it, fully public at some point.
John, what it says, if you haven't looked at BDBag, it basically either, if there's some components of it you can reuse, you're welcome to, or if you think that this is a general feature, Mike Darcy, the primary maintainer, is really good about taking contributions. So it might be something that if you got a package that we could depend on, or you actually want to contribute code, please consider it.
Do that, thank you.
So Rick, I had a question. You sort of touched on this when you were working through one of your examples, but you were talking about limiting the scope of tokens, and I think this is one of those circumstances, I think, where limitation is actually powerful, and so would it be possible, for example, for me to do something that says, okay, I'm going to limit the issuance of refresh tokens to systems with a particular IP address or IP address range?
I don't think that's applying the right solution to the problem.
Okay. I may not be thinking about it right either.
There's things you can do, and some of that is like issues where Globus Auth is awesome, where you can log in with any of your linked identities, but now we've got features that are enabling, like I'm going to show you logging into Jupyter Hub here in a second, but once a new feature in Auth lands, we're going to enable people deploying Jupyter Hub using our authenticator to specify a set of identity providers. So like Benedict at UChicago runs one where you can log in with it'll look for your UChicago ID, because in our cases, the names map well. And he's like, log in with your UChicago ID and I'll spin up an account that's RP Wagner at UChicago. But you might want one that's like, I've got 3 campuses within the University of California I want to run a Jupyter Hub instance for. So I'm going to allow UCLA, UCSD, and Santa Barbara to log into, so you'll be able to do that. But then you get to the point that I think you're trying to make. So first, let me remind everyone what scopes are in this context. Let me scope the scopes, which is a scope is basically the APIs that this token is tied to. So if I look at my data stager here, I have OpenID, email, profile, and transfer. In reality, I got to follow up with the person on my team, Lukasz, and say, we probably don't need these scopes. So this tool does not need to look at any of these 3 items unless we're going to embed some useful information about the user running it in the information to do it. Because to talk to Globus Transfer, all you need is this one. And let me show you the other reason why you don't want to have an egregious number of scopes. So I'm logging into our demo Jupyter Hub server. It's jupyter.demo.globus.org. If you're familiar with Jupyter, you can open a terminal. We have the Globus Connect endpoint in there. We have the CLI in there. But if I go to our demonstration notebook, in here, we send the tokens from logging in into the user environment so that basically you can call the APIs from within the notebook. Okay, we got it. Let's look inside this token. So these are all of my tokens that were sent to Jupyter Hub when I logged in. And the reason that I have this absolute boatload of them is because this is for training using a variety of systems. We've got Globus Search, we've got Globus Transfer, we've got Globus Identifiers, we've got FuncX and DL Hub and stuff like that. So this system ends up with many tokens. And that means that if this was compromised, somebody could reach out as me, and you'll notice there's no refresh tokens, but during this time, they could reach out briefly and do stuff as me in other places. So when I'm talking about limiting scope, what I mean is, don't issue tokens unnecessarily. Try to limit what that application is storing on behalf of the user.
Okay, cool. That makes sense. And being able to do that, I think not only is it good for users, but I think that's going to make things like, folks like HPC facilities sleep better at night. Right?
Yeah, and there's the other power of that is the fact that each of these tokens, the reason these tokens got in there is because I consented for this Jupyter Hub system to have it. So I or the resource owner can revoke these tokens from me. So if the Jupyter Hub server was compromised, we would just go in and say, all right, revoke that client, all the tokens associated with that client. It's no longer trusted until we fix it. So that gives the resource controller, so the resource owner, some permissions over it, which if you're running an endpoint is relevant. Or if I think my username and password has been compromised, I as a user can go in and revoke my tokens, including the refresh tokens, without having to touch the systems. Like, boom, immediately they're invalid. And so I've managed to negate them immediately.
Which hopefully you will do before the video is posted.
Oh, this one?
Yeah.
These will expire before the video is posted.
Excellent.
Yeah. Hence, we noticed that the refresh token is null.
Indeed, yes. Excellent, thank you. Other questions? I know that we've lost some folks because we've passed the top of the hour, and that's to be expected. But other folks have questions about all of this. I mean, I was very interested in the E3SM workflow that you talked about, and I mean, just speaking as me personally. I'd like to dig into that a little bit more at some point and get a couple of slides of summary for that. Because I think that that's a good story to tell, specifically from a DOE facilities perspective. But I think that design pattern is pretty broadly applicable. So that's certainly of interest to me. Other folks with questions, feel free to drop them in the chat. Going once. Going twice. Okay. Then I think we're going to leave it there. Rick, thank you so much for this. This has been great. And thank you all for attending and for the good discussion. We will resume the Brown Bag series in the coming weeks. Look for mail from Jason about what's coming up next. So thanks very much, everybody. Have a great rest of your day and have a good weekend.